Hi guys, here's another question for vertical projectile of motion, but we have a graph now, graph of velocity versus time. That says a ball of mass of 100 gram is thrown vertically upwards from the ground. It's very important, from the ground, with a velocity of 3.92 meters. So if you look at the graph, okay, let's read the entire statement. It says the graph below illustrates how the velocity varies with time during the first few seconds of its motion. Ignore the effect of the resistance. So if you look at the graph there, it was thrown by at 3.92. What's happening to the velocity? It decreases to zero. Clearly, this is the ground. This is what is happening there. So it's thrown there from point A, the ball from point A, it decreases to zero, which is, what is zero there? It's point B. And then from point B, it increases in the negative direction. So when it increases in the negative direction, which is, here's the increase in the negative direction, till it reaches the ground with the same velocity, which is at C. And then if you look here graphically, there's a bounce there and there's a contact time. Once you see the space there, there's a contact time there. So clearly, if there's a contact time, there will be a space there, right? And then it hits the ground with this velocity. It hits the ground with this velocity and it moves from the ground. So this is the velocity just before it collides, and it collides. And then it jump up with the velocity of what? 2.5, which is positive. As you can see, it's going up. So in the graph, they already chose for us. And it reaches the maximum point. This is what? D. And the maximum point, it's what? It's E. So if they gave you a graph, in the graph they already chose the direction for you. So this motion, it was going up here. So up, it's in the positive direction. Even it was going up here, up, it's in the positive direction. So that's the motion that happens there. So it's very important to understand that. Now it says when the ball hits the ground for the first time, it's in contact with the ground for 0.1 seconds. That's why I've said there's a contact time, because I see those broken lines are sloped, or they are diagonal in a way. Those broken line, if they were straight like that, the contact time was going to be negligible, but now it's not negligible because they are diagonal or they're sloped, their gradient is not zero. So the contact time we're given there, it's 0.1 seconds. So now the 3.1, it says define the term projectile. When we talk about the projectile, guys, we are talking about an object. A projectile is an object upon which the only force acting on it is a gravitational force. Projectile, it's the object in which the only force acting on it, it's the gravitational force, and that object is given an initial velocity. It's very important. 3.2.1, it says calculate the maximum height the ball reaches above the ground. It's very important, that point above the ground. So they want this height. So from there to there, that's what they want. So we're going to take which segment? This segment. We're going to take A and B. It's very important. So taking that segment, good people, 3.2.1, taking that segment, which is our V initial there, we're given from the graph. The initial velocity is 3.92, and the maximum height when it gets there, it's B, which is 0. So it's 3.92 meters per second. The initial, the final velocity at B is 0, and the time. Do we have the time? We're not given the time there. So what do we want? We want the displacement. So the formula that we're going to take, there's the formula that doesn't have time, but we want delta y, that has the delta y. So it's going to be vf squared v initial squared plus 2a change in y. Why are we taking that one? We have the final, we have the initial, we have the acceleration. We want that, so we only have one unknown there. So let's substitute. Final velocity 0, initial velocity 3.92 square plus 2a. Our acceleration is going to be negative because up is positive from the graph. If you see, this was a motion upwards, but it's where it's positive. If you look at our graph here, if you look at our slope of the graph here, it's a negative slope. The slope of the velocity versus time, the gradient of the velocity versus time there, it's an acceleration. So acceleration is negative. You can see even the slope there, it's negative 9.8, and the change in y. So we're going to have, so if we take that to that side, we're going to have negative 3.92 square, and we're going to have 19.6 delta y, and it's negative. We divide by negative 19.6, divide by negative 19.6 both sides. So our change in y, which is the height there, it's 0.78 meters. 0.78 meters above the ground. So this is 0.78 meters. That's the height above the ground, which is the maximum height. Now 3.2.2, it says the time taken for the ball to reach the ground. So what do they mean? The time the ball it takes to reach the ground again. So we want this time, right? So what do we have there? It's very important. We have an initial velocity and the final velocity and the displacement that is 0. So from the starting point and returning back to the starting point, the displacement is 0, and we wanted this time from the starting point and return to the starting point. And what else do we have? We have an initial and the final velocity there. So our segment is A to C. 3.2.2. Initial is what? 20 meters per second. Final, negative. No, where do I get the 20? Where do I get the 20? Initial is 3.92 meter per second, the positive, and the final 3.92 meter per second. But the negative one, the displacement there is what? Is 0. Graphically, let's look at that. Here's the initial velocity, and here's the final velocity when it returns to the starting point. Starting point, maximum height, back to the starting point. And we're not even given the time from the graph. So, which one are we going to use? Which equation are we going to use there? The equation that we're going to use there, it's very important, guys, to understand what you are doing. So, let's try this one. Vf is equal to V initial plus AT. Let's try that one. Why are we using that one? We have initial, we have final, we have acceleration at one time. That's the easiest. Let's substitute. So the final there, it's negative 3.92. The initial is positive 3.92. And the acceleration there, it's negative 9.8. Change in t. And then if you take this guy to this side, it's going to be the double of that. So it's going to be 3.92 minus 3.92 equal to 9.8 change in t, and then we divide by negative 9.8 both sides, negative 9.8 both sides, and then our delta t there for that motion, it's 0.8 seconds. Alternatively, what you can do, you can calculate the time from here to here. The initial will be 3.92 and the final is 0, and you can use the displacement, which is this. You can use that displacement, so you can get the half of that time, and then you times by 2, so it's going to be the same. Now the last question, it's not the last question. It says calculate the magnitude of the force exerted by the ball on the ground while it is in contact. right? So we want the F net. Okay, 3.3. So we want the F net, right? What do we have? The mass. The mass. Okay. Before the mass of the ball is 100 grams. So 100 grams, we know in physics we're working with kilograms. We divide by 1000. So when we divide by 1000, it's going to be 0.1 kilograms. Now, in order to get the F net, what are the formulas that we can use? So there's a formula of the impulse momentum theorem. This formula, okay, this is where we get alternatively this formula that says F net change in P over change in time. Okay, clearly we'll get to the F net here. We'll get the F net here. Do we have the time? Yes, we have the contact time. So do we have the change in momentum, which is mv final minus mv initial? Do we have the initial? Do we have the final? Yes, we do have. So we have that, we have the mass, we have the initial, the final. Let me take you back to the graph for the initial and the final. The initial velocity, remember the ball collides with the ground here. So this is the graph that shows that. This is the collision here in the graph. This is the velocity just before it collides with the wall, and this is the velocity after it collided with the wall. So technically this is our initial and this is our final, right? So let's go to our formulas. Let me rewrite the formula. So we want change in P over change in T. So it's going to be mv final minus mv initial, and then our time, change in T. And the change in T, remember guys, we were given here. It says it is in contact with the ground for 0.1 seconds. So we have that. So our mass is 0.1. The final velocity is 2.5. Which, where do we get to 2.5 again? Is the velocity after, velocity before. And the velocity before, it was negative 3.92 divided by 0.1. So these two, they cancel. So our net force there, it's 6.42 newtons. That's the force that the ball exact on the ground and the force that the ground exact on the ball. Remember, that's Newton's first third law. A ball exact on the ground, so it's positive because we chose down as positive, so it's going to be positive, the force, right? Now let's go to 3.4, the last question. Calculate. Where do I get to calculate? Draw the position time graph for motion of the ball from A to E. So they mean the entire motion of the ball from A, B, C, D, E. So we need to show that it says that with ground as a zero position. So we take ground as a zero position, so our graph is going to be similar to that. So ground is zero position, so our Cartesian plane is going to be there, so our graph is going to be like that. So simple as that. We've already done that. So it's 3.4. So here's the ground, here's the Cartesian plane. You see in the Cartesian plane, here's our zero. It's a graph of y change in t. So that's our graph, and then there's that line of the contact time, and then there. So that's our graph there. So what do we have to show there in our graph? We have to show the points. They said here, clearly indicate the following A, B, C, D on the graph. So let's show that. So it started at A to the maximum point B, and it goes to the ground C, and then it moves from the ground D, and then it goes to the second maximum point, which is E. Our graph is going to be like that. Guys, I hope that makes sense and you enjoyed that. Like and share and comment and share with your friends and families. Thank you very much, guys.